Hi guys, we are the Renewable Babies and welcome to our Renewable Novela series chapter 1 and 2.
Nasa puso lamang makikita ang tunay na yaman.
Dito sa chapter na to, pag-uusapan natin yung iba't ibang types of renewable resources, particularly yung wind farm and hydrogen power plant. We will explain it kung how it is working, kung paano ito gumana, kung paano yung proseso nito, kung saan ba yung ideal location na dapat itayo nito or kung ilang watts yung napoproduce niyang electricity, and at the same time yung mga parts na din and everything na kailangan nating malaman within these two types of renewable energy, which is yung wind farm or wind turbines and the hydrogen power plant.
For our first lesson here at EE Elective 1, wind farm and hydrogen energy, two of the few renewable energies that emits zero pollution. So, kiniklaim dito or napatunayan na rin na itong dalawang renewable energy na to or nagpo-produce ng energy na which are the wind farm and the hydrogen energy ay nag-e-emit ng zero pollution or hindi ito nakakadagdag sa pollution dito sa ating mundo. Wind turbine, a tall structure with blades that are blown round by the wind and produce power to make electricity. So, ito yung mataas na structure or tall structure na may blades na umiikot sa pamamagitan ng pag-ihip ng hangin or natural na wind. Pag tumama dun sa blade at umikot yon, nakakapag-produce siya ng electricity or ng power. Wind turbines is a type of renewable energy that harness the power of the wind to produce electricity. So yun nga, ito yung type, isa sa mga type ng renewable energies na nag-harness ng power sa pamamagitan ng air or ng wind, ng hangin, para makapag-produce ng electricity. The basic idea is that the wind turbines uses rotor with attached blades to collect wind's potential and kinetic energy. Wind turns the blades which the shaft that is connected to a generator of electricity. So, basically daw, yung wind turbine nito ay gumagamit ng rotor na naka-attach dun sa blades para makapag-collect ng potential and kinetic energy ng wind. And yung wind turns the blades which the shaft that is connected to a generator of electricity. Or yung shaft mamaya ay pag-aaralan or i-discuss namin. A large number of wind turbine is usually called the wind farm. So, ang tawag daw sa maraming or sama-samang wind turbine ay tinatawag na wind farm. Katulad na lamang nung nandun sa may Ilocos. Let's move on to parts and function of a wind turbine. Ano ba ang mga parts nito at ano yung mga function ng parts ng wind turbine? First, we have the blades. The blade is the part that rotates due to the forces it catches from the wind. Or ito yung unang-una mong makikita sa may wind turbine, yung blade, yung umiikot. Yun yung nagka-catch ng wind to produce energy. It is connected to the low-speed shaft via the hub. The low-speed shaft is connected to the gearbox and the gearbox is connected to the generator. And again, mamaya, i-discuss kung ano ba yung low-speed shaft and yung gearbox and yung generator. Once the blade rotates, it causes the rotation of the generator, thereby generating electricity. So, kapag nag-rotate na yung blade and nang dahil nun din sa generator, yun yung process or yun yung dahilan kung bakit nakakapag-produce ng electricity. Most wind turbine consist of the 3 blades for maximum efficiency. So, maximum efficiency na yung 3 blades. Yun na yung pinaka swak, kumbaga, doon sa may isang wind turbine. Kumbaga, hindi na pwedeng lumagpas pa sa 3 dahil yung blades ng isang wind turbine. Blade design. To produce an amount of power, wind turbines blades generally need to be large and tall. So, mas maganda sa wind turbine ay na mas mataas siya. It is shaped to generate the maximum power from the wind at the minimum cost. Kumbaga, ginawa siya para makapag-generate ng maximum power galing sa wind at the very minimum cost. So, ibig sabihin, hindi siya magastos. Improvements in the design has produced new turbines which are more compact, quieter, and generates more power from less wind. So, hindi siya maingay, hindi siya maugong. Its length vary at around 50 meters. Imagine 50 meters per blade. Blade pa lang yun. Isang blade pa lang yun, ah. So, bali, tatlong 50 meters long na blade ang kailangan sa isang wind turbine. And mas maganda na mas matangkad nga siya or mas malaki. And with 107 meters, currently the longest from Siemens Gamesa. So imagine 107 meters ang kailangan sa isang wind turbine para mas maganda ang pag-generate niya ng electricity. At ang yung pinakamahaba nga ay doon sa may Siemens Gamesa, which has 107 meters na kataas na wind turbine. Airfoils. Airfoils is the cross-sectional shape of the blades that determines its aerodynamics. They are key to blade design, allows the blade tips of a wind turbines to move faster than the wind is moving, thus generating more power and higher efficiencies. So, ano nga ba ang airflow? So, saan ba ginagamit ang airflows? Yung airflows, ang purpose nito ay para ma-reduce yung drag and yung makapag-generate na rin ng pag-lift. For example, while a streamlined or flat wing may experience very little drag, it may not generate enough lifting power for an aircraft to take off. Going on even further, airfoils designed for low altitude flights will look different than high altitude ones. And ito pa ang ibang meaning ng airfoils. Airfoils are highly efficient lifting shapes, able to generate more lift than similarly sized flat plates of the same area, and able to generate lift with significantly less drag. Wind turbine blades work by generating two aerodynamic forces, lift and drag. This is due to the wind and air forces. Lift and drag, this is due to the airfoils. So, ang sabi dito, nagwo-work daw yung wind turbine dahil sa dalawang forces, which are the lift and drag. Ang lift forces is perpendicular to the airflow and is in line with the drag blade rotation, while the drag force is in the line with apparent wind direction, which is in opposition of the blade motion. Drag increases in proportion to the frontal area of an object facing. So, ang lift force ay nakaayon siya sa may airflow, while yung drag force naman ay opposite naman siya ng airflow. Another thing that the airfoil is able to bring is for the blade to attain difference in pressure on both sides. The most curved side, or we may say the convex side, generates low air pressure, while high pressure air pushes on the less curved side, or we may say the side with slightly concave part. This is actually the reason for the blade rotation. Sinasabi lang dito kung ano yun, or kung paano kung bakit nagro-rotate, or kung paano nagro-rotate yung blade dun sa wind turbine. sabi nga dito, dun sa may convex side ay nagge-generates ng low air pressure, while dun naman sa may slightly concave na part, dun naman yung high pressure na nagpo-push para makaikot yung wind turbine. And here you can see kung paano talaga, or kung paano iikot yung blade ng wind turbine. So, ang sabi dito, it pushed, or is it pushed to the side that has more curve, or pushed to the side that has less curve? So, here you can see naman sa slide na to kung paano mag-rotate yung blade.
So, ayun, tuloy lang po natin yung report. Dumako tayo sa wind orientation. Okay. Wind orientation. Next. The photo shows the front side and back side as well as the leading edge and trailing edge of the blade. So, ayan, sa photo, makikita natin yung kung nasaan ba yung front side and back side ng blade natin, as well as yung leading edge ng blade and trailing edge ng blade. Okay. In addition to its design, twisted and tapered blades further enhance its aerodynamics with the combined effect of twisting and tapering the blades along its length. Improves the angle of attack, increasing speed, efficiency, and lift while reducing the drag. So, ayun nga, yung blade, yung aerodynamics, yung wind turbine blades, nag-work siya by generating two aerodynamic forces, yun nga, yung lift force and yung drag force. So, yung lift force yun yung perpendicular sa airflow, while yung drag force naman yung in line with the wind direction. Kumbaga, yung lift force yung nag-aangat ng blade, then yung or nagpapaikot ng blade, and drag force yung parang opposite dun sa motion, or siya yung combat dun sa rotation ng blade. O yun nga, kapag daw tinwist natin, saka tinaper natin yung blade, ay enhance daw yung thermodynamics niya. So ayun, na i-improve niya yung angle of attack, increasing its speed, yung efficiency na, and lift, and while reducing the drag. So kasi mas less drag, mas better eh. Ayan, next. So here is the question. Based on the previous slides, what number of blades is the best design in consideration of all the factors in construction of operation of wind turbine? So ayun nga, yun yung tanong, ano ba yung best number of blades or optimal number of blades na makakapagbigay ng efficiency and best performance? So sagutin natin yan. So the rule of thumb are, the fewer the blades, the better, since there will be less drag and increased in efficiency. So ayun nga, kapag mentras na mas onti yung blade natin, mas mainam kasi nga mas onti yung drag, mas efficient sa saka mas makakapagbigay siya ng best performance. The number of blades increases the torque and reduces the optimum rotation speed. Yun nga, mai-increase yung torque niya, and as well as mare-reduce natin yung rotation speed. Having fewer blades reduces drag. So ayun nga, kapag mentras na mas onti yung blades natin, mas less yung thrust na makakapagbigay ng best performance and efficiency. Next. So, one blade. Because of the decreased drag, one blade would be the optimum number when it comes to energy yield. However, one blade could cause the turbine to become unbalanced, and this choice for the stability of the turbine is not great. So, yun nga, dahil nga sa decreased drag, yung one blade, optimum lang siya para sa energy yield. However, yun nga, kapag isang blade lang yung ginamit natin, hindi balance yung natin, turbine. Unbalance, kumbaga ganun. Yung stability niya, hindi siya ganung paganda. Okay, next. Two blade. At first glance, two-blade turbine seems like the optimal configuration for a wind turbine. Seems like the perfectly balanced, and with one less blade than a three-blade turbine, they generate less drag. So why aren't turbines with two blades? It has a trouble yawing. Yaw is when its head or nozzle turn face the wind due to effect called gyroscopic precession. When a two-blade turbine yaw, it creates a wobble, and as the blades go from the vertical plane to the horizontal plane, which place additional stress on the mounting bearings, wearing them down faster. So yun nga, pag titignan natin, parang yung two blades, siya yung optimal configuration ng wind turbine natin. Pero and pag tinignan natin siya, parang it seems balance ganun. And ayun nga, bakit ba hindi best choice or optimal choice yung two blades? Kasi nga may problema siya sa yaw or sa yawing system. Yun yung nag-iikot ng nozzle sa direksyon ng hangin. And doon nga, dahil nga sa effect na tinatawag na gyroscopic precession, yung two blade nagto-trouble siya nagkukos siya ng trouble sa yawing system na nag-create ng wobble o pag-alog na nangyayari pag yung blade natin nag-go from vertical plane to the horizontal plane na nagkukos ng stress sa bearings na maaaring makasira ng turbine natin. Okay, next. More than 3 blades. Any number of blades greater than 3 would create wind resistance, slowing the generation of electricity and thus becoming less efficient than a 3-blade turbine. So, ayun nga. Kapag more than 3 naman, magka-create siya ng wind resistance. Ayun, napapabagal niya yung generation ng electricity. And ang downside ng naman na to, magiging less efficient yung wind turbine natin dahil nga magkakaroon ng mas malaking drag force kaysa sa lift force. Okay, blade tilting mechanism. According to the wind speed, the relative velocity angle of the wind also changes. A blade tilting mechanism is a censored coupled parts of the wind turbine. So, ayun nga. Yung blade tilting mechanism, relative siya with respect to the velocity angle. Parang, ano siya, sensor coupled parts ng wind turbine na yun nga nagtitilt ng blade with respect to relative angle of the wind, relative velocity angle of the wind. Okay, next, nozzle. The housing at the back of the blade, which contains the slow speed shaft, gearbox, generator, and other small parts inside it. So yung nozzle, yun lang yung pinaka-housing na nakikita natin sa wind turbine, na doon nga nakapaloob yung mga parts na slow speed shaft, gearbox, generator, and other parts. Okay, gearbox. The component which converts the slow rotation of the blade into the faster speed. This is needed simply because the rotation of the blade generated from the force of the wind is usually not enough for a generator to achieve a grid quality voltage output. Most generators need to be turned at 1500 RPM for 50 Hz and 1800 RPM for 60 Hz. In no way it is feasible for a turbine for a blade to move that fast. So ayun nga, minsan napunta kami sa Ilocos Norte, may wind farm doon, and nung nakita ko siya, yung ikot niya hindi naman ganun kabilisan, and pumasok sa isip ko, paano nakakapag-generate ng electricity yung ganung speed. So ayun nga, dito pala yun, dahil pala sa gearbox, yung slow rotation ng blade na nakikita natin dun sa yung slow rotation na nakikita natin, pinabibilis ng gearbox in 90:1 ratio. Sa isang ikot ng wind turbine, 90 times yung katumbas nun sa gearbox. So ayun, parang kung titignan kasi natin, hindi naman sapat yung ikot na yun para makapag-generate ng electricity. Kaya nga, ayun, may part tayo na tinatawag na gearbox na pinabibilis yung ikot nun. Gearbox. A common ratio is about 90:1 with a rate 16.7 RPM input from the rotor to 1500 RPM output for the generator. So ayun nga, yung ratio na is 90:1 is 90:1, and yung rate niya from the input 16.7 RPM lang, pero yung output niya doon sa generator 1500 RPM na. So ang laking difference, di ba?
Direct drive gearless. In a direct drive turbine, there is no gearbox. The main shaft spins the generator directly, causing it to spin at the same speed as the turbine blades. Comparing to gear type, the slow rotation and decrease in moving parts of PMD, the generator, reduce fatigue and stresses on the turbine, resulting to reduced noise and vibration, longer lifetime, and lower cost of maintenance. So yung direct drive turbine is mas better kasi malalaman natin kasi nga nare-reduce yung noise, vibration, longer lifetime, and lower cost of maintenance. Doon pa lang sa mga advantage na malalaman na natin na mas better yung drive turbine compare sa gear type. One main disadvantage make up for its slower rotation. More magnets are added to create the required frequency and power. This increases the diameter of the generator, which makes it a larger and often heavier than gear type wind turbine. So malalaman natin ang disadvantage nito is yung pag nag-add siya ng magnets, pumibigat siya. And yung diameter generator, which makes it a larger. Hindi lang siya, yun nga, pag lumalaki syempre, diba, pumibigat. So yung parang disadvantage niya. Another thing is that the additional magnets being used in this type is made up of neodymium, which is expensive. So yan, malalaman talaga natin na parang ang mahal niya kasi diba nga yung magnet na ina-add or yung ginagamit doon is yung neodymium na expensive na. Turbine have prevented it from presenting major competition to the gearbox turbines until recently. But other experts claims that direct drive technology will eventually come the dominance since the gearbox wind turbine is almost at its maximum efficiency point, while the PMDD generators have more possibilities for improvement. So yun nga, malalaman natin na ang PMDD generators have more possibilities for improvement. So malaki yung potential ng project na to, and malaki pa siyang i-improve kapag pinagpokusan siya. So expert na rin yung nagsabi. And next, brakes. The brake system in a wind turbine is a protective device coupled with sensors which automatically stops the rotation of the blades whenever it detects activities that could harm the system during operation. Very high wind speed, vital parts not working, maintenance in power, and etc. So yung brake system, ito yung nagpapahinto sa sa wind turbine kapag pag nakaramdam yun nga ng very high wind speed, vital parts not working, and maintenance in power lines. Yung parang brakes yung yung magsasabi kapag kapag i-stop yung yung wind turbine. Parang protective device siya kapag may mali sa system niya, ganun. Yaw system. Yaw system is a sensor-equipped mechanism consisting primarily of yaw motor, yaw drives, and others. Its function is to automatically rotate the nozzle on the top of the tower so that he sets of blade is facing the wind directly at all times. It detects its proper direction through the electronic information being fed by the wind being located at the back. This ensures that the wind turbine is producing the maximum amount of electric energy. So yung yaw system, ito yung nagbibigay ng sensor or equipped mechanism consisting primarily of yaw motor. Ito yung nagbibigay ng information sa may wind vane. Dito malolocate kung okay ba yung mga turbine. Ito yung mga parang dito talaga nagpo-produce yung from the word electric energy. Dito na po-produce yan. And next, tower. Wind velocity increases at higher altitude. This means the taller the tower, the greater electricity it can produce. Majority of wind turbines are supported by conical tubular steel towers with a height of usually 75 to 110, 250 to 370 feet, depending on the blade's diameter. The tallest is still for completion in the mid of 2022, which is 280 meter, to be installed at a test center in Western Jutland, Denmark. So malalaman dito natin na mas mataas yung tower, mas maraming electricity ang nakukuha niya. And 280 meter pa lang ang pinaka mataas na natatayo. Yun ay sa Western Jutland, Denmark. So ito yung tower na yan. Makikita natin yan. Tower, yan. Makikita natin sa picture na habang tumatagal is nag-i-improve talaga yung tower or tumataas. Syempre kapag tumataas, 'di ba? Mas madaming electricity ang nakukuha niya. Yung nabasa natin kanina. So ayan. Ideal location of wind farms. The best place for wind farms are coastal areas, at the tops of rounded hills, open plains, and GPS in mountains. Place where the wind is strong and reliable. Some are offshore. So mas effective nga yung wind farms sa mga coastal areas kasi rounded hills, kasi dun yung pinaka madaming source at pinaka malakas na source ng wind. To be worthwhile, there should be at least an average wind speed of around 25 km per hour. So, ganito kalakas yung speed dito sa mga nasabi na ganito na 25 km per hour. Advantage, yes, and disadvantages. Advantages and disadvantages. Wind is free. Wind farms need no fuel. So, yun nga yung, syempre, diba, libre lang naman yung hangin and di na siya kailangan ng fuel. So, malaki ang matitibig nun. Produce no waste or greenhouse gases. So from the word greenhouse gases, malaking tulong to para sa ozone layer natin, and hindi siya nagpa-produce ng waste. So napakalang tulong sa environment natin to. The land beneath can usually still be used for farming. So nasa tabi ng farm na yun, sa tabi ng windmill na to, pwede mong taniman ng farm, di ba? Kasi nga, bago mo itayo to, syempre, di ba, magaganda yung wind. So, goods na goods to sa mga sa pagpa-farm. A good method of supplying energy to remote areas sa mga, sa mga shore, di ba, sa mga hill, pwede maging source ito ng electricity sa mga lalayong lugar. Disadvantages. The wind is unpredictable. So, di naman natin alam na kung saan yung malakas yung hangin, mahina yung hangin. Kasi pabago-bago yung panahon. So, yun nga, the wind is unpredictable. Next. Suitable areas for wind farms are often near the coastal area where the land is expensive. Alam natin sa panahon ngayon na ang mamahal na ng mga lupa, lalo sa mga coastal area, na grabe yung presyo. Next, can affect television reception on nearby places. Di ba nga sa mga hangin, kapag di maayos yung TV mo, hindi maayos yung signal mo. So, baka hindi ka makapanood ng ayos dahil dito. So, yeah. Thank you po.
So ngayon is pumunta naman tayo sa chapter 2, which is the hydrogen power plant. So ano nga ba yung tinatawag nating hydrogen power plant? So hydrogen power plant is a concept designed for a new widespread source of electricity. Essentially, it is a facility which uses hydrogen to produce electricity. So, yung hydrogen power plant, yung main part niya is the hydrogen fuel cells. So, yung hydrogen power plant daw is ginawang concept design para mapalawak yung ating source na pinagkukuhanan ng electricity. So, yung iba pang ibig sabihin ng hydrogen power plant is a large tank of liquid hydrogen will feed into thousands of hydrogen fuel cells. These fuel cells are solid structures containing an electrolyte fluid and two terminals. Parang katulad ito ng batteries. So, para mas maintindihan pa natin yung hydrogen power plant, eto. So, ano nga ba yung working principle ng hydrogen power plant? So, large tanks of liquid hydrogen will feed into thousands of hydrogen fuel cells. These fuel cells are solid structures containing an electrolyte fluid and two terminal much like batteries. So, as you can notice, ang main part nga ng hydrogen is yung hydrogen fuel cells. So, before natin ma-analyze yung working principle nitong hydrogen power plant, dapat alam muna natin or dapat nating maintindihan how the battery works, leading into the working principle nitong si hydrogen. So, the reactant flows into the cells, in this case, hydrogen and oxygen. They intermingle with the electrolyte to produce an electrical charge and water as a byproduct. So the water flows out another part while the electricity is siphoned off the terminals and held in gigantic multi-ton batteries. So the electricity resides in the batteries until it is needed, in which case it is sent out through the local power grid just like any other type of power plant. So yun yung tinatawag na working principle ng ating hydrogen power plant. So meron tayong battery parts and function. So alamin natin ang mga basic concepts ng battery since ito ay related sa hydrogen power plant. So sa hydrogen power plants, meron tayong vital parts ng battery, katulad na lang ng electrolyte, anode, and cathode. So, electrolyte is a chemical compound that conducts electricity by changing into ions when melted or dissolved into a solution.
It can be a liquid or paste-like substance. So, yung electrolyte daw, ito ay chemical compound na nagkakandak ng electricity sa pamamagitan ng pagpapalit nito into ions kapag ito ay na-melt na or na-dissolve into a solution. So, i-explain pa natin yan maya-maya lamang. So, sa electrolyte, meron tayong ammonium chloride, zinc chloride, potassium hydroxide, lithium, tin phosphorus, sulfide, and sulfuric acid. So, anode is the negative or reducing electrode that releases electron to the external circuit and oxidizes during the electrochemical reaction. Ang parts naman ng anode is zinc, metallic, lithium, and lead. So, cathode is the positive or oxidizing the electrode that acquires electron from the external circuits and is reduced during the electrochemical reaction. Example naman ito is the manganese dioxide, carbon, lead dioxide, and copper. So, alamin natin ang mga para mas maintindihan natin yung body parts and function. Yung anode is the negative side and yung cathode is the positive side. And para mas maintindihan kung paano nag-i-interact si electrolyte, anode, and cathode, narito ang schematic diagram of a battery. Ito yung tinatawag nating schematic diagram of battery. So, kung makikita natin is meron tayo ditong electrochemical cell. Ito yung tinatawag nating electrolyte solution. Itong blue part is the anode. And then, itong part na to is the electron flow. And itong side na to is the positive side, which is cathode. And then, itong nasa gitna, ito yung tinatawag nating semi-permeable barrier. So, paano nga ba nag-i-interact si electrolyte, si anode, and si cathode? So, ito yung explanation. So, dito, makikita kung paano mag-i-interact ang vital parts ng battery to one another. So, makikita naman natin na nakasubmerge yung anode and si cathode dito sa ating electrolyte solution. Diba, nakikita naman natin na nakasubmerge si anode and si cathode sa ating electrolyte solution. And nakapagitan nga sa gitna niya yung semi-permeable barrier. Yung purpose ng semi-permeable barrier is para ma-prevent na mapunta directly sa kabilang side yung excess electrons nitong si anode. So, ulitin ko, yung role ni semi-permeable barrier, itong nasa gitna or itong nakapagitna, is para ma-prevent niya na mapunta directly sa kabilang side yung excess electrons nitong si ni anode para mapunta sa cathode area or sa positive area. So, paano siya magwo-work? Alamin naman natin kung paano magwo-work. So, sa side nitong si anode, sa side ng anode, itong kulay blue, yung electrolyte at yung anode forms a chemical reaction para makaproduce ng excess electrons. So, ulitin ko paano nagwo-work. Itong si anode or sa side ng anode or sa negative side, yung electrolyte and yung anode nagpo-form ito ng chemical reaction para makapag-produce ng mga excess electrons, making this side na negative part. So, diba alam naman natin na kapag madami ang electron, patuloy itong mag-move into random direction. Ulitin ko, kapag madami ang electron, patuloy itong nag-move or continuously moving into random direction. So, paano naman nagwo-work itong si cathode or itong sa positive side? So, si cathode naman, yung electrolyte at yung ating cathode, nakakapag-form din ito ng chemical reaction in a way na nagpo-produce naman siya ng substances nagpuproduce siya ng substances na tumatanggap ng electron. Kung itong si anode is nagpuproduce ng excess electron, ito namang si cathode is nagpuproduce naman ng mga substances na tumatanggap ng electron. So, yun yung pinagkaiba ng anode sa cathode. Yung anode is nagpo-produce ng excess electron. Ito namang si cathode is nagpo-produce ng chemical reaction nagpo-produce siya ng substances na tumatanggap ng electron. So, si anode is the negative side and si cathode is the positive side. So, paano sila nag-i-interact yung anode, yung cathode, at yung excess electrons? So, yung excess electrons ng anode, itong excess electrons na napuproduce ng anode is magta-travel ito ngayon towards the cathode. And yung cycle na yon is paulit-ulit lamang na mangyayari. So, yun nga. Ulitin natin para mas maintindihan. Etong si anode is yung anode and cathode is nakasubmerge sa isa't isa. Then, ito yung tinatawag natin electrolyte solution. And in the semi-permeable barrier, ito yung nakapagitna sa ating anode and cathode para ma-prevent na mapunta directly sa kabilang side yung excess electrons sa anode. Yun yung role ng semi-permeable barrier. So, next naman natin is the chemical reaction to zinc-carbon battery. Meron tayo sa anode, meron din tayo syempre sa cathode, electrolyte, and sa anode. Sa anode, meron tayong zinc. Sa cathode, meron tayong manganese dioxide and carbon is added to increase conductivity. And then, sa electrolyte, meron tayong ammonium fluoride. So, may note tayo. The exact mechanism for this is complicated and there is still controversy over the exact mechanism. However, the approximate half-cell reactions are anode and cathode. So, meron tayo, ang ibig sabihin lang nitong chemical reaction to zinc-carbon battery is, so meron tayong, alam naman natin na meron tayong iba't ibang uri ng batteries, at yung batteries na yon meron silang iba't ibang uri ng chemical reactions. So, dito sa slide na to, hindi naman natin madidiscuss para maintindihan nyo yung chemical reactions to zinc-carbon battery. So, i-discuss natin yan mamaya sa mga next slide natin.
So, hydrogen fuel cells. So, let's read it first and we will briefly explain kung paano ba ito nangyayari or paano yung proseso ng hydrogen fuel cells. What is the working principle of it? So, fuel cells work like batteries. So, etong hydrogen fuel cells or yung fuel cells ay similar siya sa battery but they do not run down or need recharging. Unlike sa battery kasi, di ba, pwede natin siya i-recharge or pwede na rin natin siyang i-dispose. They produce electricity and heat as long as fuel is supplied. A fuel cell consists of two electrodes, a negative electrode or the anode and the positive electrode or the cathode, sandwiched around the electrolyte. A fuel such as hydrogen is fed to the anode and the air is fed to the cathode. In the hydrogen fuel cell, a catalyst at the anode separates hydrogen molecules into protons and electrons, which take different paths to the cathode. The electrons go through an external circuit, creating a flow of electricity. So, the proton migrates to the electrolyte to the cathode where they unite with the oxygen and the electrons to produce water and heat. So, may video tayo dito, ipapakita natin kung paano ba nag-work to then explain natin. Para mas ayan. So sa video na ito yung fuel cell na to consists of two electrodes. Yun nga yung anode and cathode. So, sa anode, meron tong mga diatomic molecules which is yun nga yung hydrogen fuel na e-emit ng tawag dito, nag-e-emit siya ng or yung hydrogen fuel is being fed to the anode. So, the hydrogen fuel, kapag ka napunta na siya dun sa pinaka gitna dito sa may catalyst, magse-separate siya into two molecules, which is yung protons and electrons. So, ang susunod na mangyayari doon, since etong catalyst, meron dito sa gitna niyan, meron siyang PEM or yung proton exchange membrane. So, it only allows the proton to cross to the cathode. So, matitira dyan yung electrons. So, ang gagawin ng electrons dito o yung molecule na electrons ay maghahanap siya ng different path para ma-unite siya dun sa protons sa kabila, sa cathode. So, dito nga siya dadaan dito. Yan. Sa circuit na yan. So, kapag dumaan siya dun, magkakaroon na ng flow of electricity. So, since hindi naman ito battery, continuous lang siya na nagfo-flow without need of charging. So, pagka napunta na dun yung electron sa cathode, magkakaroon siya ng pag-unite doon kasama yung diatomic molecules ng oxygen, which the electrons produces only water and heat. So, yun lang. So, water and heat lang siya, creating, yun nga, water vapor. So, I think hydrogen fuel cells or yung gawa neto is not harmful to our environment because it is less on pollution dahil nga ang ini-emit lang nila is water and heat, which is yung magkakaroon na water vapor. Yun. So, next tayo. Why explore it? So, bakit nga ba natin kailangan explore yung this type of things? Kasi fuel cells have several benefits over conventional combustions based on technologies currently used in many power plants and passenger vehicles. So, itong fuel cells kasi, hindi pa siya, I think, masyadong wala pang masyadong kaalaman dito, or if marami man, hindi pa nare-reach yung greatest knowledge about dito sa hydrogen fuel cells, or mas marami pa tayong may explore dito sa hydrogen fuel cells. So, hydrogen is a very efficient fuel source. Yun nga. So, number one, maganda siyang fuel source dahil unlike gasoline daw, which is nandito nga, unlike gasoline, itong hydrogen nga is capable of producing more energy per round of fuel than gasoline. So, kung isipin natin na itong hydrogen, pwede siyang magpamalit or maging alternative dito sa gasoline, and at the same time, mas efficient siya kasi mas madaming energy na napoproduce or pwedeng i-emit yung hydrogen kaysa sa gasoline. Plus, itong hydrogen is very eco-friendly dahil nga ang ini-emit niya lang is water, much more than gasoline, which is nagkakaroon siya ng pag-emit ng mga pollutants such as carbon dioxide na makakaharm sa environment. This means that an equal size of a tank of hydrogen fuel will give out vehicle greater range and more power when filled with gasoline in an internal combustion. So sabi nga natin na mas efficient nga ito. Fuel cells have much lower emissions than a combustion engine. So yun nga, sinasabi natin, yun nga, nabanggit ko kanina, di ba, yung fuel cells, mas marami itong benefits kagaya ng, yun nga, eco-friendly, mas magandang alternative source kaysa sa gasoline, alternative source for electricity. Plus, ang hydrogen fuel cells only emits water. So, hindi siya makakapag-harm or hindi siya magkakaroon ng damage sa environment natin kasi nga, water lang yung ini-emit niyang or yung nagiging output ng device kasi nga, yun nga, water. There are no carbon dioxide emissions. So, walang carbon dioxide emissions and air pollutants kagaya nung sinasabi natin kanina. Next, ito, schematic diagram of hydrogen power plant. So, explain lang natin to kung ano yung video na to. So, dito sa schematic diagram natin, itong H2 pipeline, itong O2 pipeline, o yung hydrogen pipeline and then the oxygen pipeline. So, ito yung hydrogen fuel cells. So, as we all know na itong hydrogen fuel cells need neto like I think more than 1,000 devices neto para capable siya to produce enough energy. So, yun nga, itong tank, na dalawang tank na to, magsusupply sila ng mga diatomic molecules dito sa hydrogen fuel cells natin. Then, mag-e-emit siya ng electricity kasi nga, di ba, kagaya ng sinabi natin kanina doon sa previous video, doon sa isang diagram na continuous siya as long as it's being fed with fuel ng hydrogen. So, ang magiging output na nito is warm water out. So, yun lang yung mapoproduce niya. Walang pollutants, walang mga carbon dioxide. Then, at the same time, meron siyang electricity na dumadalo which is yung direct current na electricity. And, ang need na dito na invention or devices is para ma-convert natin tong DC into AC is an inverter. So, pagka nagkaroon na ng pagko-convert ng DC to AC, mapupunta na siya sa grid transformer and then masusupply na siya to the local electric grid. So, yun yung schematic diagram of hydrogen power plant. So, why it hasn't gone mainstream? So, dito explain natin kung bakit hindi siya ganun ka sikat na renewable energy resources natin. So, hydrogen productions through methane. About 95% of hydrogen used today is to produce by a process called steam reforming. Itong steam reforming, ito yung separating hydrogen atoms from carbon atoms in methane. So, ang process na to is very expensive and it will release greenhouse gases which will contribute to global warming, thereby canceling out any benefits of the environment. Hydrogen production through water, yun yung next natin i-discuss. So, di ba yung alam natin yung methane, this is a type of gasoline. So, di ba, sabi nga natin, itong gasoline is harmful pagka naging, di ba, sa mga vehicles, alam nga natin, pagka nag-emit sila ng smoke dun sa may tambucho is, alam nyo yun, very harmful yun sa environment, which nagkakaroon ng butas mo sa ozone layer. Kaya tinigil to, which nga nag-release nga daw ng mga greenhouse gases which will contribute to global warming. So, hydrogen production through water. The other production method is electrolysis. Ito nga yung isa sa kung bakit hindi nag-gone through mainstream o hindi ganun ka sikat kasi nga this type of production o yung pag-produce ng ganitong type of power plant which required electrolysis nga, which it is the process of separating hydrogen from water. The downside it is that it expensive. Yun nga, sabi natin, mahal for hydrogen to reach its full potential as an energy source. So, habang tumatagal, parang yung mga scientists is parang they need to figure out the way to produce it inexpensively kasi napakamahal ng proseso ng electrolysis kaya hindi siya nag-go through mainstream. So next nga dito is yung cost. Yun nga, so sabi natin sobrang mahal. The cost of fuel cells can be high given the use of platinum as one of the largest component materials. However, there is work underway to find non-platinum catalyst approach. So, dito sa hydrogen storage, scientists are still struggling with the challenge of how to store hydrogen because it is such a low energy density. Hydrogen needs to be kept under a strong compression and to be viable fuel source, necessitating strong tanks and heavy-duty fuel lines. At is currently no mainstream system of storage and distribution of hydrogen fuel. This is a major practical disadvantage. So, ito nga, isa din sa mga problema nga dito sa bakit hindi siya nag-gone mainstream is that yung hydrogen storage, kung nagkakaroon sila ng challenge on how to store pure hydrogen. Kasi nga, this type of element, it's not being mixed or hindi siya compound, kumbaga pure hydrogen lang siya. So scientists are still finding out on how to store hydrogen at its best para makapag-create ng energy resources na on its full potential. So hydrogen leak. Hydrogen leakage can occur during many steps of its production and use. Scientist magazine report in June 2003 that the hydrogen leakage from widespread use of hydrogen fuel will gobble up ozone layer faster than CFCs or yung chlorofluorocarbon. So, itong event na yung hydrogen leak, this is very I think it is very harmful to the environment. So sabi nga dito kasi kapag yung hydrogen leakage daw, mas malala ito kaysa sa mga greenhouse gases na i-gobble up yung ozone layer faster than the CFCs or yung chlorofluorocarbons. That's why it hasn't gone through mainstream. So, the latest development. So, dito ipapakita natin yung mga latest development projects kung saan dito nakagawa sila ng mga hydrogen power plants. So, Long Range Generation Project. Touted as first of its kind power plant in the United States. In the Long Range Energy Generation Project at 485 megawatts facility being equipped to run a mix of natural gas and carbon-free hydrogen. It is nearing completion at its sites of a former aluminum smelter on the banks of the Ohio River. So, kung susumahin po natin yung Long Range Generation Project, only produces 485 megawatts. Unlike dun sa mga previews or dun sa wind farm and wind turbines natin na thousands yung na po-produce nilang megawatts, dito wala pa tayo sa thousands, kumbaga 485 pa lang, so wala pa sa 500, but ditong hydrogen power plant nga na to is eco-friendly or hindi siya harmful sa environment. The facility first will burn a fuel blend that includes 5% hydrogen in the General Electric Co. H gas turbine. The plant is intended to transition to 100% green hydrogen over the next decade by relying increasingly on renewable resources to power electrolysis machines that splits water into hydrogen and oxygen elements. So, eto nga yung electrolysis machines. I think this is very expensive kasi expensive yung process nga nung pag-separate ng etong compound element natin, which is yung water. Meron nga siyang, di ba, H2O, hydrogen and oxygen. So, this process is very expensive na kung paano lang kukunin yung hydrogen through electrolysis. So, kaya hindi siya masyadong mainstream din kasi nga mahal yung pagde-develop ng hydrogen power plant. So, the next is the Siemens Energy. Construction begins on the world's largest green hydrogen power plant, part of the unique base load solar project. The Siemens Energy will operate a unique 170 million pound facility in a remote part of French Guiana, which will provide 10 megawatt of power during the day and 3 megawatt power at night. So, sumahin natin dun pa nga sa wind power plant, which yun napoproduce at thousands, tapos doon sa may nasa Ohio River, yung Long Ridge 485, dito ang napoproduce lang 10 megawatts during the day and 3 megawatts at night. So, parang kung iisipin natin napaka mahal niya gawin, but at the same time, it will help us create a more sustainable and eco-friendly or zero polluted land kung ito yung gagamitin natin, but it's really expensive kung siguro kung tatagal man mas mapifigure out na ng ibang mga scientist or even me na halimbawa nakagawa ng solution on kung paano magkaroon na power plants na hindi ganun kamahal. So, yun, titignan natin in the future baka mas mura na gawin yan. And eto na lang yung gawing energy resources natin. So, yun lang po. Sana po madami po kayong natutunan sa wind farm and sa hydrogen power plant. Thank you for listening, and this is us, the Renewable Babies. Thank you for listening. Until the next video, see you next time.